All right, hey guys. We're gonna do indirect sympathomimetics. What's an indirect sympathomimetic? All right, so basically you have tyrosine kind of like transported to nerve terminals. So there's dopamine transporters, okay? That. There's norepinephrine transporters. It's like what the D, right? Let's talk about the D right here. So we got one right here, tyrosine transported to a nerve terminal. We got this tyrosine will go to like this L-dopa, and then from the L-dopa forms your favorite dopamine. Everyone knows this process. All right, that's like kind of cool. But what can it cause? A D1 receptor is your contact. Okay, you know what? We're gonna have to like do like continuous scroll or some shit. All right, so here you go. So you got this one D1 receptor, single rope swinging, D2 receptor found in CNS. We all know that. Everyone knows that. Has dopamine on D1, so there's like increasing like alpha 1 like pressure like effects. Okay, med dose dopamine D1. Increases so it causes both beta 1 and your favorite alpha 1. So it's like a two thing. So low dose dopamine on D1 that can cause like an increase in like renal blood flow. Just kind of remember that. D1 is your GS, okay, but D2 that's your GI. You gotta remember that. Important point to remember. Let's look at some other ones. So you got norepinephrine transporters. You got cocaine right here, which is like sort of both. What does it do? It inhibits the NET and the DAD. That's amazing. Now cocaine, because it leaves catecholamines floating in the presynaptic vesicle. So beta blockers cause like severe like hypertension. You got steam coming out of his ears, and cocaine like intoxication. So that's kind of cool. That's what you get here. Then if you have those, it can also cause like agitation. So it can cause like pupillar dilation. Look at his eyes, kind of like dilated. Hypertension, tachycardia, nasal atrophy. So you got nasal stuff, septal perforation, coronary vasospasm. Nice. Now there's another thing here where there's like norepinephrine, which is like dopamine then goes to form norepinephrine in a vesicle, and that's your catecholamines. Really, that's really what it is. Your nori, your epi, and your dopamine. That's all your favorite stuff here. You got some other ones like tetrabenazine, which like sort of goes against your VMAT. You got the reserpine, which like also inhibits VMAT, so you got a lot of stuff here. You got a friend of mine, amphetamine, that's displaced catecholamine synapse, okay? So it puts them into this little box of synapse, okay? So stimulants that suppress appetite. So you got like methylphenidate, that's kind of like a derivative, so it's used to treat ADHD. Fast acting used for terminal ill with like decreased life expectancy. Yeah, that's methylphenidate. You also have modafinil, that's for like stimulant for like narcolepsy. Now, a vesicle containing NTs in a presynaptic neuron. That's what you get here. That's in a presynaptic neuron. Cool. All right. Also, a vesicular monoamine. That's VMAT. What is it? It's a vesicular monoamine transporter. That's really what it stands for, and you gotta know why it stands for that. So you got that meat tyrosine prevents tyrosine to L-dopa conversion. That's what meat tyrosine does. Okay. That's kind of cool. Adrenergic nerve terminal site of action is your doc. Adrenergic nerve terminal. That's where the site of action of all this stuff. All right, cool. That was kind of cool. All right, we got indirect sympathomimetics. Next up, we got